So welcome back to the class on a power semiconductor drives. In this class, we are going to discuss about some other numericals. Here, we are going to solve the three numericals, which is highly depending upon the fundamental torque which is developed in a motor. We know that the torque developed in a motor is equal to the load torque and four quadrant operation of a motor. We are going to do the one more problem. So totally, we are going to solve the three numericals in this class. The drive has a following parameter. The generator torque P equal to 150 minus 0.1 N Newton meter, where N is the speed in RPM. The load torque TL equal to 100 Newton meter. Initially, the drive is operated in a steady state. The characteristics of load are changed to TL equal to nothing but load torque equal to minus 100 Newton meter. Calculate the initial and the final steady state speed. In any drive, the generator torque equal to the load torque. See here, the generator torque equal 150 minus 0.1 N equal to 100 Newton meter. This is the first case. Then you have to solve for the N. You're getting the 500 RPM. The second case, the load torque equal to minus 100 Newton meter. So again, we're using the same formula, generator torque equal to load torque. The expression for the generator torque is given. That is the 150 minus 0.1 N equal to minus 100. Again, you find the N. You're getting the value 2500. Now we are going to see the second problem. This is the problem which is based upon the four quadrant operation of the hoist. A motor load has the following details. In quadrant 1 and 2, the generator torque equal to 400 minus 0.4 N Newton meter, where N is in a speed in RPM. The motor is coupled to the active load. The TL equal to nothing but load torque equal to plus or minus 200 Newton meter. Calculate the motor speed for the motoring and braking in the forward direction. When operated in quadrant 3 and 4, the generator torque equal to minus 400 minus 0.4 N Newton meter. Calculate the steady state speed. In this case, the first and two quadrants, the generator torque is given 400 minus 0.4. Here, load torque is given plus or minus 200. So, on the x-axis, you have taken the torque, and the y-axis, you have taken the speed. The first quadrant, the T equal to 400 minus 0.4 and TL equal to 200 Newton meter. We know the formula in any quadrant, generator torque equal to the load torque. Now, if we equate these two and find out the value of speed, we are getting the 500 RPM. The same manner, the second quadrant, the torque value is given 400 minus 0.4 N and TL equal to minus 200 Newton meter. Because in the second quadrant, the torque is a negative, low torque is negative. So again, you are using the same formula, that is the generator torque equal to load torque. Then you have to equate these two equations, then find out the value of the speed. You are getting the 1500 RPM. In third quadrant, the generator torque equal to minus 400 minus 0.4 and load torque equal to minus 200 Newton meter. Again, use the same formula in third quadrant, that is generator torque equal to load torque. Then you have to find out the speed. You are getting the minus 500 RPM. The similar manner you have to find out for the fourth quadrant also. The fourth quadrant, the generator torque equal to minus 400 minus 0.4 N, load torque equal to 200 Newton meter. Then again you have to equate these two and find out the speed. You are getting the. This is the way in which you have to calculate the speed of a motor by equating the generator torque and load torque in each quadrant. Now we are going to see the one more numerical, that is a drive has a following equation for the motoring and load torque. The T equal to 1 plus 2 omega m and TL equal to 3 root omega m. Apply the equilibrium point and determine the steady state speed. This is some interesting problem. See here, the generator torque equal to the load torque. We know this one. Then you have to equate these two. So to remove this root in a right hand side, scaling the both sides. If you scale the both sides, we are getting the quadratic equation in terms of omega m. Then you have to solve for the omega m. You're getting the two values, that is 0.25 and 1. Now you have to check whether which speed is the stable. Initially, you have taken the omega m is nothing but a speed of a motor in radians per second. Now you have taken that value omega m equal to 1. Already we have discussed about the steady state stability of a drive. The system is steady state stable only when the rate of change of load torque is greater than the rate of change of motor torque. Now we are using that condition. See, this is the condition: the rate of change of load torque is greater than the rate of change of motor torque. We know the expression for the load torque. So now we have to differentiate this expression with respect to the omega m. Then you have substitute the omega m equal to 1 in that expression. So dTL by d omega m equal to 3 by 2 root omega m. In place of omega m, you substitute the 1, we're getting the 1.5. The same manner, we differentiate the t with respect to the omega m, we're getting the differentiation from the 1 becomes 0 to omega m becomes a 2. These values becomes a 2. So the generated torque is greater than the load torque. So this condition is not satisfied. So the omega m is not giving a stable operating point. Now we are going to check out the same thing by means of by taking the omega m equal to 0.25 radians per second. Again, we are finding the rate of change of load torque. Substitute the value of omega m equal to 0.25. We are getting the value. The same manner, the rate of, if we find the rate of change of generator torque, we are getting the value 2. Rate of change of load torque is 3. The rate of change of generator torque is 2. This is greater than the this one. So this condition is satisfied. So the steady state speed of a motor becomes a 0.25 radian per second, which is giving a stable operating point for the drive. See, in this manner, sometimes you have to check whether the speed of the motor is giving a stable operating point. So if you have any doubt, you can ask me directly, or you can ask in the comment box of my YouTube channel so that I can answer all your questions. Thank you very much.